Okay, so we will be learning about imaginary numbers, right? And how to combine complex numbers today. So earlier, all throughout this chapter, actually, we saw that when we had a square root of a negative number, we could not combine them. Do you recall that? So when we had square root of negative 4, we've been saying it was undefined, right? Now we're going to define what this is. So there's a number I that's equal to the square root of negative 1. So when you actually square I, it's equal to negative 1. So this is the definition of the imaginary number. So imagine if you had a, a, right? That's a positive number. Let's say a is equal to 4. So if I had the square root of negative a, as we can see down here, the way we would write this in terms of I, the number I, would be we have to separate this negative 1. So it's not visible here, but you're going to have to use the square root of a times the square root of negative 1, like that, right? And as we just defined, the square root of negative 1 is I. So this is the square root of a times I. Now, so that people don't get confused, we usually write the I in front of the square root so that people don't end up writing it like this, right? It's not this. Okay, so make sure if you do write the I after the radical. Um, please make sure that the square root is just over the A and the I is outside the radical. So you could even just put a square root like this. Okay, but I would prefer it this way. There's no confusion then. Okay, so let's do the square root of negative 4 down here. So square root of negative 4. So if you were to separate these, right, you don't have to write this intermediate step here, but I just want people to be aware of what's going on, right? This square root of negative 1 is my I. So this is the same thing as saying square root of 4 times I, right? So that's why this is 2I. Does that make sense? Or actually, I should write the step in between. So this is the square root of 4 times I, right? That's why this is 2I. Okay? Now let's look at B. We have a negative before the radical, right? So that's going to affect our final answer at the end. We have to look at the square root of negative 9. So I have negative square root of negative 9. I'm going to separate these. So this is negative times the square root of 9 times square root of negative 1. So there's my square root of 9 times I, right? Which is negative 3I. Is that clear for everyone? So once you get comfortable with the idea of the square root of negative 1 equals I, you could skip that altogether and just replace it with I. So for example, in part C, the square root of negative 8. So I'm just going to write this as the square root of 8I. And I would have to simplify the radical 8, right? So all radicals that can be simplified must be simplified. So what is square root of 8? That's the square root of 4 times the square root of 2 and then times I, right? So square root of 4 is 2. So I'm going to write the 2 and the I first and then the remaining radical 2. Everyone clear with that? Last one. Square root of negative 7 is equal to radical 7 times I, or as preferred, I radical 7. Any questions with this? Almost everyone is able to do it. Very few people are not able to. Okay? All right, so square root of negative 25 is square root of 25 times the square root of negative 1. And you could skip this, as soon as you're comfortable. You could just start writing square root of 25 times I instead, which is now equal to 5I, right? I only write it so that people seeing it remember, oh yeah, I is equal to the square root of -1, right? Okay, so the second one, we have the square root of -24 is equal to the square root of 24 times the square root of -1. And we need to simplify this radical 24. So that is radical 4 times radical 6, right, times my I here, which is 2I radical 6. Okay, any questions? All right, scrolling down, we're going to see that we use these i's in complex numbers, right? So this 2I radical 6 we did earlier, right? You can see um, that the I is right there. That's going to be part of this plus bi. You'll see later on. Okay, so just keep in mind, a plus bi is the form that we write complex numbers. So complex number means there's an a and a b, which are real numbers, and then with b there's an I. Okay, so this is the standard form, right? And in the standard form, a represents the real part. A is the real part, and b is the imaginary part. Okay, and this combined is called a complex number. So let's look at how to combine complex numbers, right? Through addition and subtraction. Okay, so for the complex number a plus bi and c plus di, right? So a, b, c, d all represent real numbers. So how do you combine them? So let me, sorry. So if I had a plus bi and I was going to combine it, right? Let's say I'm combining it with c plus di. So these complex numbers each are basically groups. So that's why we put parentheses around them when we first add them, right? So now you look at, you're supposed to remove the parentheses, and you have to use your rules for that, right? So the parentheses here we can just remove because it's a plus before, right? This one doesn't have, so you can just remove. So it's a plus bi plus c plus di, right? So now I'm going to combine the like terms. So a and c are the real parts, so I can combine a plus c, and then I have plus bi plus di. So these are combining like terms, right? So in the end, my real part is going to be a plus c, and then plus b plus d times I. Okay, so this looks complicated, more complicated than it actually is. I'll show you an actual example, and this is it's really simple. So as you can see here, we have 5 plus 3i plus 6 minus 7i. So first we remove the parentheses, so we get 5 plus 3i plus 6 minus 7i, right? And after that, we combine the real parts. 5 plus 6 is 11. Then I have positive 3i minus 7i. So what is that? That's minus 4i, right? 3 minus 7 is negative 4, right? And don't forget the I. So that was really easy, right? Let's look at this next problem. We have 5 plus 7 minus 5i. So the first number doesn't have an imaginary part. It has just the real part. And the second one has both the real and the imaginary. So we have to remove parentheses first, right? So we have 5 plus 7 minus 5i. So we combine the real parts. 5 plus 7 is 12. And minus 5i. So there's my complex number in standard form. A plus bi. So just real quick, let's identify what the a and b is. What's the a? It's the real part, right? The a is 12, and the b is this minus 5, this negative 5. Okay? For the previous one, we have a is 11, b is negative 4. Okay? Part C, we have 8 minus 2i minus 3 minus 4i. You see how this is a minus sign in between? So first, I'm going to remove parentheses. So 8 minus 2i. And as you can see, this minus sign needs to distribute. So this becomes minus 3 plus 4i. Okay, so that's the importance of parentheses before you start to add them, right? You have to, or subtract them, you have to make sure the parentheses are there so you can distribute. All right, let's combine like terms. We have 8 minus 3 is 5. Negative 2i plus 4i would give me 2i, right? Where the real part is 5, the imaginary part is 2. Okay, I'm just writing these down so that you recognize what the real part and imaginary parts are. All right, with that, I want you to try these 3 problems. Let's remove the parentheses, right? So the first one or actually both of them we could just remove. They're both positive. So we have 4 minus 7i plus 3 minus 2i. So combine the real parts. 4 plus 3 is 7. Negative 7i minus 2i is minus 9i, right? So the real part is 7. The imaginary part is negative 9. Part B, we have negative 7, and then you can just remove the parentheses because this is a plus sign. So this is minus 2 plus 3i. So negative 7 minus 2 is negative 9 plus 3i. Any questions? All right, remove parentheses here. This is just negative 4 plus 3i. You have to distribute this negative. So this is plus 2 plus I. So the real part, negative 4 plus 2 is negative 2. 3i plus I is 4i. There you have it. All right, moving on. Let's look at some multiplication. So the multiplication is actually, you'll notice it's just like in chapter 5 when we were multiplying binomials or polynomials, right? It's like foiling, right? So let's say we have 2 plus 3i times 3 minus 4i. So we're going to basically distribute, right? It's like foiling. When we did foiling, 2 times 3, right? 2 times 3 is 6, right? 2 times 3. And then 2 times negative 4i is the second term. So this is like first, outer, inner, and last. So the inner is 3i times 3, and then the last is 3i times negative 4i. Okay, so hopefully that's pretty clear. So 2 times 3 is 6. 2 times negative 4i is negative 8i. 3i times 3 is 9i. 3i times negative 4i is negative 12i squared. Now the thing to remember is from our definition of the imaginary numbers, we said I is equal to the square root of negative 1. Therefore, I squared is equal to negative 1. Right? And what do you see here? You're going to see 6 plus negative 8i plus 9. And over here you have an I squared, right? Negative 12 times I squared. We're going to substitute that I squared with negative 1. Right? This is my I squared equals negative 1. So I just substitute that and this becomes positive 12. So we have 6 plus I plus 12 is 18 plus I. Okay, does anyone have questions with what just happened here? All right, so let's do the second problem. Our first term is 1 times 3. Our outer is 1 times negative 4. our inner is negative 2i times 3, and our last is negative 2i times negative 4i, right? So this is my first, this is my outer, this is my inner, and my last. So 1 times 3 is 3. 1 times negative 4i is negative 4i, plus negative 2i times 3 is negative 6i, and then negative 2i times negative 4i is positive 8i squared, right here. Right? And we said I squared is equal to negative 1. So we replace that I squared with the negative 1. So this is 8 times negative 1 is negative 8. And then you combine the real part. 3 minus 8 is negative 5. And then minus 10i. Okay, so let's try this practice problem on the bottom. And don't forget to FOIL, right? So when you FOIL, you should get the first, the outer, the inner, and the last. So I'll give you a minute. So we have 2 times 3, right? Let me write down the steps here. 2 times 3 is my first, plus 2 times negative 2i, plus negative 5i times 3, plus negative 5i times negative 2i. Right? That's my first, my outer, my inner, and my last. Did you all get these parts right? So 2 times 3 is 6, and then 2 times negative 2i is minus 4i. Negative 5i times 3 is minus 15i, and the last term is plus 10i squared. Right? And we know that I squared is equal to negative 1. So we have over here I squared equals negative 1. So this becomes 10 times negative 1, right? Which is minus 10. So I have 6 minus 10 minus 4i minus 15i. And that is equal to 6 minus 10 is negative 4. Negative 4i minus 15i is minus 19i. Okay. Let's try some more. Now, yeah, this is what we were doing just now. So let's say we have a problem like this. This should look familiar, right? As you can see, this is like our A plus B times A minus B. Do you remember these? These are the difference of squares, right? So this is A squared minus B squared, right? Difference of squares, or difference of two squares. So as you can see here, this is like my A, right, minus B, and this is like my A plus B, right? A is 7, B is 4i. So if I were to follow this formula, you have A squared, which is my 7 squared, right? And then minus B squared, which is my 4i squared. So what's 4i squared? That's 16i squared, right? 4i squared is 16i squared, which is then equal to 16 times negative 1. So that's just negative 16. So anytime there's an I squared, the easy thing to do is just reverse the sign of this number, right? So this 16i squared would just be negative 16. Does that make sense? All right, so since this is minus, right? So this is 7 squared minus negative 16, right? So this is 7 squared minus, or actually 49 minus negative 16. That's the same thing as 49 plus 16, which is 65. Okay? So let's look at this one on the this problem on the bottom. So we have, you could FOIL it, right? But if you remember the formula, it's just 5 squared minus 3i squared, right? So this is 25 minus 9i squared. I squared is negative 1, so this is 25 minus negative 9, right? 25 plus 9 is 34, right? And alternatively, you can FOIL it, right? If you were to FOIL it, you would get, first is 5 times 5 plus 5 times negative 3i plus 3i times 5 plus 3i times negative 3i. That's the FOILing method, right? So this is 25 minus 15i plus 15i minus 9i squared. So this is longer because this first way, once you get comfortable with it, you can kind of do most of it in your head, right? So this is what? The middle two terms cancel out to 0. And you have 25 minus negative 9, which is 34. So yeah, you can FOIL it, but I would, try to remember the formulas for these. Okay, and lastly, let's look at some division. We're going to just do 2 of these, and yeah, let's look at this. So we have 6 plus 9i over 3i. Now, when you have an imaginary number in the denominator, we have to get rid of that. It's kind of like when we have a radical in the denominator, we have to rationalize the denominator, right? And the way you do that is to multiply by what you call the conjugate. And the conjugate is always the opposite sign of the imaginary number. So that's what we multiply this by. So, oh, shoot, sorry. Whoops. How did that happen? Okay. So the denominator is 3i, so the conjugate of 3i is negative 3i, as you can see here, right? So the conjugate of 3i is negative 3i. So we multiply the numerator and the denominator by negative 3i. So as you can see here, we have 6 plus 9i over 3i, and we're going to multiply this by negative 3i over negative 3i. All right, and the numerator, because it's more than one term, is in parentheses. Don't forget, the fraction bar here is a grouping symbol, so that's why the parentheses are not written, but you should know that they're there. So let's distribute this. 6 times negative 3i is negative 18i. 9i times negative 3i is minus 27i squared. Denominator is negative 9i squared. So the I squared we're going to replace with negative 1. So this becomes negative 18i plus 27 over positive 9. Does everyone get that part right here? This is negative 1, right? Negative 1. This is times negative 1. So negative 27 times negative 1 is positive 27. Negative 9 times negative 1 is positive 9. Right? Okay, so we have to write this in standard form. Standard form means a plus bi. Okay? Standard form. Right now it's written as one fraction. So we have to separate these, right? We have to do negative 18i over 9, right? And we want to write the a first. This is our imaginary part. So I'm going to put the plus the 27 over 9 as the real part first. So this is equal to 3. And this second part is minus 2i. Okay? I hope that's pretty clear for everyone. So let's move on to this example here. I want you to try it, multiply by the conjugate, and put it in standard form. So the conjugate here is negative 2i, right? So we have to multiply this by negative 2i over negative 2i. Let me zoom in a little bit here. Right? The conjugate, meaning the opposite sign of this imaginary part. So that's why it's negative 2i. So now we have to distribute, right? We have 4 times negative 2i is negative 8i. And then 10i times negative 2i is minus 20i squared. Over this 2i times negative 2i is negative 4i squared. So now we can replace the I squared with negative 1, right? You multiply both of these by negative 1. So we should have negative 8i, and this is now plus 20 over positive 4. So I'm going to write the real part first. So I'm going to put the positive 20 over 4 and the negative 8i over 4. So 20 over 4 is equal to 5 minus 2i. Did everyone get 5 minus 2i? Very good. All right. And last but not least, we have a list of i's. We're not going to be worrying about this too much, but that's good. Congratulations. We're going to be seeing more of this, actually more in depth, when you go to Math 6. So like Rosa, you're going to be seeing this pretty next level when you get there. Okay, so you see how we have I is equal to square root of negative 1, right? I squared is negative 1. I to the third using our power rule of exponents. Do you remember the power rule of exponents? Right? When we have x to the a times x to the b is x to the ab. So I to the third is equal to I squared times I. And as you can see, I squared is equal to negative 1. That's why it's negative 1 times I, which is just negative I. And I to the fourth is equal to I squared times I squared, which is negative 1 times negative 1 is positive 1. I to the fifth. So since we already know what I to the fourth is, we're going to split it up to I to the fourth and I to the first. So that's 1 times I, which is positive I. So as you can see, I to the sixth, we're going to keep using I to the fourth because we know what that is, right? And then I squared, we know is equal to negative 1. So 1 times negative 1 is negative 1. And this pattern repeats, you'll be able to tell. It goes from I, negative 1, negative I to 1. I, negative 1, negative I to 1. So every four terms, that's when it starts to repeat. So that means I to the ninth is equal to I. I to the 10th is equal to negative 1. I to the 11th is equal to negative I, right? And I to the 12th is equal to positive 1, right? So every 4, it keeps repeating. So if I were to give you just a quick example here, I to the, let's say, 73rd power. Do you know how I would solve this? You see how it's repeating every 4 times? So I take the exponent 73 and I divide it by the pattern of 4. And if I do that, I get a remainder of 1. Do you all see that? So 73 divided by 4 is 18, remainder 1. That means it goes through this 18 times. Do this pattern 18 times, and then the remainder tells you how many more to go. So it's the first one. So this is equal to I. right? If I gave you I to the 75th power, I would do the same thing, 75 over 4. And I know that this is going to be 18 again, right? Um, let me see here. Oh, shoot, sorry. This is 4, 3, 5, and this is 32. So the remainder is 3, right? And by the way, 72, I'm sorry, 73 was remainder 1, so 75 should be remainder 3, right? So that's 1, 2, 3. So that's the third term. So I to the 75th power is equal to negative I. So yeah, those of you going to Math 6, we're going to be delving much deeper into these complex numbers.